Hey everyone, welcome to part two. In part one, we finished off talking about a stoichiometry problem involving a single displacement reaction between zinc and hydrochloric acid that was a moles to mass stoichiometry problem. Now we're going to go through mass to moles problems and mass to mass problems. So, a mass to moles problem. In this example, we are asked how many moles of water are produced when 28.3 grams of sulfuric acid reacts completely with sodium hydroxide. So I've already written the equation here to save time, but remember, you may not always be given this, and you may have to recognize that this is an acid-base neutralization reaction, and the products of that would be a salt and water. So, how many moles of water are produced when 28.3 grams of H2SO4 reacts completely with sodium hydroxide? So, first steps would be to write and balance our equation and then determine the given and the unknown. We are given the mass of sulfuric acid, which is 28.3 grams. And we are trying to find the moles of water as our unknown. And this makes this a mass to moles problem. That's how we identify that. So the first step is we're given a mass, but we cannot compare masses in stoichiometry because masses do not tell you about the amount of atoms in a compound. That's what we need moles for. So we first need to find the moles. We have to take our given mass and convert that into moles, and then we can use that to solve the rest of the stoichiometry problem. So, for sulfuric acid, if we want to find the moles of that, we know that moles is equal to the mass over the molar mass. And we are told we have 28.3 grams of sulfuric acid, and the molar mass of sulfuric acid is 98.079 grams per mole. Right, our grams cancel out. That's how we know we are looking for the right units. So 28.3 grams divided by 98.079 grams per mole will give you 0.288542,909 moles of sulfuric acid. I'm not going to round this yet because rounding too early in a problem can accidentally give you a wrong answer. I'm going to save this number in my calculator for later, and I'm going to round only at the very end. So I'm going to set up this number. We have the moles of sulfuric acid. And then we're going to set up our conversion factor. So I'll just put moles sulfuric acid. We're going to set up our conversion factor by looking at the reaction equation. So if we have moles of sulfuric acid and we're looking for moles of water, we're going to have to set up this conversion factor so that the units we don't want cancel out and leave us with the units that we do want. And we do want moles of water, and we don't want moles of sulfuric acid. So I'm looking to my coefficients, which are 2 and 1. So the conversion factor would be 2 moles of water over 1 mole of sulfuric acid. And this makes sense because in this reaction equation, this is the same as saying for every 1 mole of sulfuric acid that reacts completely in this neutralization reaction, you can produce 2 moles of water, theoretically. For every 1 mole of sulfuric acid, you could produce 2 moles of water. Or you could say that as there are 2 moles of water per every mole of sulfuric acid. So our units there would cancel out. And then what we're left with would be 0.577085,818 moles of water. And then now that we're finally at the very end, I'm going to round that to 2 decimal places. And that is our final answer for this question. 0.58 moles of water. We have found our original unknown, and we have solved the question. How many moles of water are produced when 28.3 grams of sulfuric acid reacts completely with sodium hydroxide? 0.58 moles of water are produced when you have 28.3 grams of sulfuric acid reacting completely with this sodium hydroxide base. So I'm going to end this video here just for the sake of time and ease of uploading it to YouTube. So this has been the mass to moles example of stoichiometry problems. I'm going to do one more example that is going to be on the mass to mass problems. Those ones take the longest and they have the most steps. So I want to be able to have enough time to go over that. Again, all these videos are optional as an extra resource, but if you don't feel confident with stoichiometry problems yet, please look ahead to the next video.